Thank you. So, hi. Good morning. Uh, so, probably right now. So I'm going to talk about again modularity. I was talking the previous days about module systems, sandboxing, some magical stuff sometimes. Today I'm going to talk about the not so fancy parts, the dirty parts. That I think it's important to know that we are doing the dirty job too, and why it's important. So, you probably know me. I will not reintroduce myself. So, if you are watching this on YouTube, go to my other presentation to see it. No, I don't have. Yeah, if I had the link onto YouTube in the future, that would be actually pretty nice. So you probably know me from this presentation or this other presentation. Yes. So, but today I'm going to talk about this. Do you know what this is? No. It's a graph. What does it represent? Huh? Yes, dependencies. This is a dependency graph. Of what? Packages. Which packages? Faro packages. Yeah, actually, this is the Faro kernel in 2016-17. So this is what we bootstrap. Yes. So I'm going to go into details a bit about what are the steps of the bootstrap, because it was funny when I was in Argentina last year for the small talks. People was asking me, the bootstrap, are you still using it? And I said, yeah, it's in production since 10 years already. So yeah, the fact that you don't hear about it is because hidden. Nobody has ever to deal with that, but it's there. And every time that you commit, we are building a new image from scratch. So that's actually happening. So this is what we call the minimal image. I will explain exactly what that is. But at this point in time, it was 53 packages. I did a similar graph before this presentation. So I try to do the same colors. I am not good at doing graphs. It doesn't matter. The point is that like 1 week ago, we were in 25 packages. What is the delta? Well, so these 28 packages that are not there anymore, well, they are now loaded at later stages. Now, working in this, I don't know, I call it the hair diagram, yeah, because it's like full of hair. You don't understand anything. So you don't see the real dependencies there. You cannot touch that. So what is happening behind the scenes when we work on that? Yes. So this is many people actually doing dependency analysis, refactoring, redesign of libraries that are badly designed. We are trying to do that while keeping compatibility. So this is this is the not fancy work. It's very difficult. We are not publishing on this. So, and my job is to publish. So we are doing this just because love, yeah, and sometimes because I like to go to war with this kind of stuff. I'm going to come back to this. But before, so I wanted to. You don't see anything here. So okay, this is the CI job. I promise you that the ticks and these things are little circles, and then there are arrows here. Yeah. So what happened? So this is our stages in the build system, and this is what happened up to last year. Let's say. So there are many stages, and then at the end we are running the tests. So the first stage is what we call the bootstrap. The bootstrap is we are generating a minimal image with these 53 or 25 packages. These are built from sources, and the result of this step is a small image that doesn't have a UI, doesn't have almost anything. It can do some I/O. Actually, it can load binary code, like it can load bytecode. It can read files, write files, kind of that's it. And then from there we build up. Yeah. So actually from there we build up. The next step of the job was to now we have that. We are going to load the rest. We take thank you. So we put Metacello in there, and then using Metacello, we load the big baseline that loads everything. Yeah, everything that you know, Morphic, the tools, Iceberg, everything is loaded in that step. Um, okay, so that works. And then we upload the file, the result of the files to our file server. That's okay. And finally, we are running the tests on each of the platforms. So we are running Linux, Mac, Windows. Right now, we are running them on 64 bits only. No. So now, this works, of course. It's not very agile from my point of view, so it's okay. I still can deal with that, but the problem is that every time that we have a problem, the feedback arrives too late, because actually this takes time to execute, and these tests are executed really at the end of the full process, where maybe we shouldn't do it like that. Yeah, so there are other problems, like for example, the tests are running once you have the full system. So for example, your test for your package or the test of the network package are run in the system that has Morphic. So we have no way to ensure, at least by construction, that there are no dependencies between the networking package and Morphic. And actually, maybe the tests are green because Morphic is there. But what if we remove Morphic? Maybe the network test will break. So I probably convinced you from the sandboxing presentation on Tuesday, that there are crazy dependencies over here and there. So I would like to test that actual packages, they don't break each other, that they have the right dependencies. Yeah, so a package should not break other packages. Running the test in one side, it shouldn't break the test in the other side. So fortunately, the guy, how do you say the perezoso in English? So this guy, it's called Flash. I don't know if you saw this movie, but actually it's Slaughter. Yes, Sloth. So actually he's very fast. What can we do about it? I will show you some of the things that we are doing to get better here. So what are the main ideas? We want to check as early as possible. I don't want to wait an entire full build to know there is a bug in a small package. Yes. We want to control dependencies. I want to know if there is a package that has a dependency to the other side of the room. Well, maybe that's not right. I don't know. Also, so this goes part of together. I'm going to talk how we do that with the strict mode, strict loading code. And then we also want to control side effects. So because I not only care about static dependencies. Sometimes, yeah, I can point to that guy, but then at runtime, maybe I am pointing to somebody, but it was not in the code. That's something that happens just when the execution unrolls. So the last year we were improving the CI. Again, I let you trust me that you have steps. And when you see steps that are one below the other, it's because they are done in parallel. Yes? So here, all this in parallel, and those in parallel. So what are the differences between this setup and the previous setup that I showed you? First, the bootstrap is exactly the same. So it generates the minimal image from sources, same as before, no changes. And then one of the things I did was to split the big chunk of loading the rest of the system into small parts. And now the next step is just to load Metacello. Yes, so we do a minimal Metacello installation on top of the bootstrap image. And so this is just the same as before. I just split the thing in two. And actually that opens the door to many different and nice stuff. Like for example, so I will talk about that just later, because actually what is important is that this stays for now the same as before. Once we have Metacello, later we are going to load the rest of the system and then run all the tests in the full system just as before. So this we don't change. But now what we added in the middle are these steps. Now, what are we doing there? What we can do now that we have a small Metacello step in the middle is that once we have a small image, we can load one package. We can run the test of that package without all the noise of the rest of the system. So I can, for example, load the networking package, run the test of the networking package without Morphic. And I want to ensure that network works without Morphic. I want to ensure that the compiler works without Morphic. I want to ensure that SUnit works without Morphic, and so on. Or maybe I want to ensure that the compiler runs even if networking is not there. Sometimes there's crazy stuff that we can find in Faro. Technical debt. it's called now. So how does this work behind the scenes? Now is this just these 3 lines of code? This is just, we are calling Faro. We are passing the Metacello image that I was talking you about. So this is the bootstrap image plus Metacello. It has the compiler inside, of course. And then on top of that image, we are going to install 2 things. First, we install SUnit because I want to run tests. And if I don't have SUnit, I cannot run tests. And then I install your project, or whatever project, and I install the group tests. Yes? And once I have that, I have an image that is able to run stuff, and then I can just run the test of your project. Yeah? So I will, some of the things here, I don't know if you are used to using Faro in the command line. Some of the things, these things are new. Some of the things were already there from before. So, Metacello, we are using Metacello to load the test and to load the library. That was already before. We had a Metacello command line. We already had a test command line from before. Now, what is new? So we have this strict option. The idea is that, so we, before the time, I'm going to say it like that. Before we were able to load code that had broken references. Yeah, so you can load code that was pointing to classes that are not there, or you can load code sometimes that has wrong syntax, and the compiler says, yeah, I will fail at runtime. Well, maybe you don't want that. Maybe I don't want that. So this strict mode says, okay, from now on you can compile code, but only if it's right. If it's not right, I will not let it pass. And I made it optional because I know that sometimes we have this kind of little issues, and the time, so it takes time actually to port a library from one version of the system to another version of the system, to remove dependencies. It takes time to refactor. It takes time to actually improve the quality of systems. So this is an option. It's not by default, but it's what we are using right now in the CI every time. And it rejects broken code, just that. And what is broken code, we can refine that in the future. Even we have the same option if you are using Metacello. In 4.14, you can, every time that you load Metacello, some package using Metacello using the programmatic script, you can tell Metacello to be strict, and this actually will eventually tell the compiler, don't get, that code cannot get in there. Yeah. This third thing that we did was that now we have some kind, we are trying to enforce more coding conventions, project conventions, and we can exploit them in different ways. So for example, here, we are, every time, if you define a baseline that has a tests group, then this, that baseline is automatically compatible with this system. Yeah, so we can integrate a baseline that has a test group with this, actually a core and a test here. And that means that if we want to right now integrate a new baseline into this testing system, then we need to refactor the baseline, make it follow the rules of all the other baselines, and then like that, everybody's the same. And now, once you have that, the other thing that we can do is that we can exploit that in the test command line, because now every time that you run the test, before you had to specify the packages that of the test manually. So you had to say, okay, I want to test the packages that are called like this, like this, like that. Now what you can say is to give a project name, which is the baseline name, yes, and it will automatically fetch the test from your project. And you don't have to specify the package names. You can refactor your baseline, change the packages, have more packages, less packages, rename them. I don't care. This will work. You just have the same package name, the same project name. Yes? So, and with this, we have first step to have package verification in isolation, which is pretty important. So I think it was in December, I don't know. I already did this, and then a couple of months ago, we had an intern that is called Nathan that started to work in these parts of the system too, and then he added a lot more of these things. And just for the sake of it, I will tell you all, one by one, all the things that he did. So he made, so as I did SUnit, the kernel, and the compilers. Yeah, so I made sure that the compiler can run without in these isolated images. But he did the files package. sync character encoders, the session manager, system platforms, announcers, the shift class builder, the command line, file system library, finalization, system support, system versions, collections, refactorings. He did also, I will not talk about it, Steph already talked about it. He did a command line debugger, so you can debug from the command line in Faro, this when you don't have a UI yet, which is kind of important in this moment. And he put the test of that there too. So he of course, at some point we were asking ourselves, okay, yes, we need to put Morphic here. Yes, except that Morphic actually is, so has a lot of dependencies and has a lot of dependencies that have dependencies and so on. So if there's one of the dependencies of Morphic, the transitive dependencies that do not follow the strict rules of loading, then I will not be able to load Morphic. So actually what we're doing here, we're going bottoms up. Yes, we take the packages that have that don't have dependencies, and then we put those here. And once we have those that are done, we know that they work. Now we can actually build on top, and we say, okay, now we can express with this system all the packages that depend on the leaves. Yes. So we are still working on it. It's a lot of work. Because, of course, every time that you want to do one of these, this looks like, yeah, it's green. Yeah, so, but no, actually, behind the scenes, we are doing that. Nathan, he's a third-year student, and he's going there, opening baselines, going with the machete, cutting dependencies, trying to understand them with the dependency analyzer, refactoring code. So it's a really complicated work for somebody that knows the system. Imagine for somebody that is there for just a couple of months. So. Of course, this joins a bigger effort. So this kind of goes in the same direction of all these things. So this, I have a reflective reference. So that is self. So of course, I talked to you yesterday about the sandbox. For the YouTube people, I will not go fast. I will go very fast on this. So please check the video of the show as your project. So. The point of the sandbox, again, is not to control static dependencies, but dynamic dependencies. I don't want to be, so I want to be able to control side effects. Maybe I want all these AI agents, I want them to not be able to write to objects that they don't own. Yes, so maybe if you have an MCP server and that MCP server has an evaluate tool, maybe you don't want it to be able to do anything. So we need to be able to control this stuff. So the sandbox works by code rewriting so far. We are going to implement a faster version with some JIT compilation soon. But the main idea is that assignments and every side effect is going to be trapped, and it's going to throw an error if you are inside the sandbox. If you are not inside the sandbox, everything will be fine, and you're not going to pay any extra price. And then, of course, I put this there in place. I hacked it, like I like to say, to run the tests in a sandbox. So what's the goal? Yes. So of course, in the long term, I would like to have a module system. I would like to have strict loading. I would like to have strict linking. So if you don't have the dependencies loaded, maybe you have a problem in your baseline, in your project configuration. We need to have better conventions. Like that, we can build better tools. Yeah. So otherwise, if everybody has their own rules, then making tools that work on top of that, it's a mess. Yes, and we can only have AI tools that try to go around them. But if we enforce some little rules, like, okay, we are going to name this like that, maybe the world will be better for everybody. And we also want to have some runtime isolation guarantees. So what do I learn? So these are things not that I learned, but I reinforced it because I already knew them. I'm just becoming older and then more conservative maybe with these things. So Faro at some point had this philosophy of, okay, I'm going to be relaxed. Yes, so I will let you compile anything. Yeah. But the problem is that leads to fragile systems that break maybe because of strange reasons, and debugging those systems is complex. I want something. I understand why having a relaxed system when you are developing is very nice, because I code in the debugger all the time. But I also want to have something in production that doesn't break. So how can we have the best of both worlds? Yeah. So I want everything. I want to have a relaxed rules at that time. When I'm coding, I want to do whatever I want. Yes, I am an expert. Sorry, I know what I'm doing. So let me do it. If I want to do true become nil, maybe I know. But maybe let it be strict in production. Yeah. So once the developer is not there to help the system move forward, yeah, it's in the machine, it's in the server. The developer is not in the server helping. So okay, let's make it strict. Yes. And of course, we want feedback as fast as possible and as precise as possible. So every time that we write a test that is checking some rules, try to make that test self-understandable. I want to be able to read the test, understand why it's breaking and what is the rule that it's checking. If I read the test and I don't understand why the test was there, how can I fix the test if I don't know what the test was testing? So other things that I learned. So the sandbox exposes design smells, things that are strange. So for example, most of the tests that break inside the sandbox break because of their writing to share singletons, of course. But now there are other strange stuff that I caught. Like for example, every time that you have a regex in Faro and you're trying to match something, that has a side effect on the regex instance. I don't know why, don't ask me. So that means that regex has an instance variable inside, and when you're matching, it is writing to the instance variable. Is it a typo? Is it in purpose? I don't know. But the point is that, for example, microdown has a class variable that has a regex that is shared with all the tests and all the execution of microdown. So every time that you try to run the microdown test in isolation, the test will break because they are trying to write to a regex just for matching. So I don't know, maybe we need to redesign the regex to remove that. There are a lot of libraries. When we were testing on Tuesday during the Show Us Your Project on the Technology Awards, I show you just debugging some tests. There are a lot of places where, I don't know, you run a test and suddenly, boom, it is pointing to a morphic progress bar. Yeah, okay. Bad exception handling, we can discuss later about the exact issues. Other things that happen on the language side. Yes, so we are asking ourselves, okay, maybe the programming language has issues. Yes, and this thing is exposing those issues. So, and for example, Faro has system services, runtime services. Like, for example, every time that you concatenate a symbol with a string, or you take a string and you say a symbol, that creates a new symbol. Yes, and when you create a new symbol, of course, symbols need to be unique, so they go to a global table. And that global table is a global table. So that means that maybe a test is writing symbols to a global table. Should test pollute the global table? I don't know. Maybe it's a yes, maybe it's a no. That's something that we need to decide. And maybe we need to decide it as a community, not myself. Should test be able to do 1 second wait? Should test go and subscribe stuff to the finalization registry? Or compile code? I don't know. Even more, so what about I/O? Should test write without any permission to the file system, to your file system? Yes, so should they read and write test? What about FFI? Maybe you know that an FFI call is harmful, or maybe it's harmless, I don't know. It's really... and maybe we want to control some primitives. So which primitives? Maybe there are some primitives that are safe and some others that are not. So we need to actually take this now, open the body, and start to dissect. And say, okay, okay, this is safe. Okay, let's put it back, and so on. So what's next? I want that the list that I showed you gets bigger and bigger. Yeah, I want to have every package in Faro in that list, actually. And eventually, maybe that has to be different jobs in different places, different machines. I don't care. But I need to be able to know, I take the smallest Faro thing, and I can load any package, automatically will load the dependencies, and make sure that that runs without any external noise. And that takes a lot of work. Yeah, we need to redesign stuff, and sometimes we need to cut dependencies. So the sandbox, so I show you the sandbox. The sandbox is slower. Yes, it's slowish. So because I just did a prototype to be able to play with this stuff, I was more caring about the dependencies and understanding what are the bad dependencies than actually making something that is production ready. I didn't care about that. But actually, if we put it to production, we can probably use it every time and actually find these kind of problems for every place. And I don't know, you can use it. But I want to expose these design issues somehow and easily. I want to have fast feedback. So I want to have better debug support somehow. So Nathan was working on a command line debugger, and there was this idea of also having a command line profiler. Sometimes you want to know what is happening in your code in the server, and you do have a UI. So you want to profile that code, extract the results, and I don't know, bring them to your machine and understand the performance. And I talked to you about extension methods the other day. We are also working on automatic migration from the old system to the new system to be able to make it as transparent as possible. So those are the things that are kind of in the next steps, like short term. And with this, I finish my presentation. Thank you very much. If you have questions.
Thank you.